What's up guys, welcome to another video, and in today's video we're gonna do a spring back problem, as you can see from what I'm showing here. So the simulation gonna be of this roller shape, which we're gonna apply the force or the displacement, and then we're gonna let go of that displacement and see how the roller gonna vibrate. So now let's go to the preprocess and try to mesh this ruler. Okay, we go to mesh and shape measure, and we go to 4-node shell. Okay. So the ruler gonna be 300 millimeter long and 20 millimeter in width. So we start from 0, 0, 0, then we go in the X 300 and 0, 0 and 0, then here will be 320 and 0, and the last thing gonna be 0 and 20 and then 0. Click on create first, and you can see here is your ruler. Okay, I would like to increase the mesh or the elements in the X direction because it's gonna be bending in this way. In the Y direction, the elements doesn't matter, actually doesn't matter that much, because the bending gonna be in the X direction. You're gonna bend down like this. So you increase the mesh, say it's 30, and then this one we call it ruler, and accept. Alright, and done. Okay, now we're gonna fix this end, and we do it from here, model, create entity, and then boundary, SPC, spatial point coordinate, create. In this small box, you click by node, by area, and then you highlight this one. Okay, now you selected all the 6 nodes, 1, 2, 3, 4, 5, 6. Okay, you fix it all, degree of freedom, XYZ translation is fixed, and rotation XYZ is also fixed. And then you click on done. Okay. Oh, sorry. You click on accept first. Click on accept. You can see here 1, 2, 3, 4, 5, 6. Then you click on done. Okay. There are different ways to do this, to fix the boundary conditions, and I've shown the other ways in different videos, but this is a method that I haven't shown before. And now you go to SPC set of node, and let's say this one is free end. I call it free end. Now we select by area, node by area, and then we go to this side, and you have 6 nodes selected. So 1, 2, 3, 4, 5, and then apply. Okay. This one is fixed, and this one we're gonna apply the displacement on this side, and the displacement, let's say, it's gonna be only 1 millimeter. Okay, so go to keyword. Now you have the boundary already there, boundary SPC set. You open, you can see the node set number 1, node set this one, this node set, and all fixed. And here I can just rename it, although it's not compulsory. It's just a good practice. So I call it fixed end. It is a good practice because if you want to give this file to someone else, then they would know what the heck are you doing. or if you are dealing with multiple parts and very complex geometry and you have a lot of boundary conditions, so it's good to identify each one of them. Okay. Enough talking, let's go to the next one. Now we want to apply the displacement in this site. Okay, so we do that by boundary prescribe motion set. I will click here. Okay, now set ID, we have the free end. Okay, done. And then degree of freedom, we're gonna push it in the Z direction, so we're gonna be 3. Okay, is it velocity or acceleration or displacement that we're gonna apply? VAD. We're gonna apply, click here, we're gonna apply displacement, so you put here number 2. Now load curve ID, so we have not defined yet, but it's okay, we can click here. You have not defined any curve yet, so you say fine. Okay, you click on this one. Now it will directly go to here, define curve. Okay, so you define the curve, new ID, and then you say displacement, and here you put 0, 0, and time is 0, displacement is 0. So you click on insert, and then when the termination time, I will set it to 1, and the displacement is also 1 millimeter. Then insert, then accept. You can see here curve ID number 1 is already there, and you can see here displacement. Accept. Okay, you close this one, click on model, you see what you have done and what you have not done. Okay, from here we need to define the thickness of this ruler. So you go to section, shell, new, and say shell thickness, or shell section. This is 3 millimeter. Hit enter, and the rest you can leave it as default. It's not very complex simulation, so we don't need to go into deep about these two. Okay. Now we need to apply, or we need to define the material. Okay, so here I want to save first. Browse, go to desktop, here, ruler, and save. Okay. Why I'm saving? Because I wanna import the material model in an easy way, or I want to import the material properties in a very easy way. So this is the file that we did, and we just save it now, this one, and you can see it just appeared just now. It wasn't there until we click save. Now I close this one. I can open this one with any text editor. Here I'm using Notepad++. Okay, so this is what we have defined, what we did right now. And then I open this file which I have downloaded from online. I've given the link. I've shown you where to find it, and I in a different video, in a previous video, and also I will give you the link in the description. So just open this file, and then we are using this. We are using kilogram, millimeter, and millisecond. Find, let's say, stainless steel. Stainless. Okay, let's say I'm using this. So what I'm going to do, I'm just copying this until here. Okay, copy all this Don't copy this this dash. Because I don't think it will recognize. So after you copy it from the file which has the properties of the material, you just make a space in your keyword after you open it with the text editor, and then you paste and just check the formatting is okay. So this is what I have input right now. Okay, everything's okay. You just need to change this material ID. So the material ID, I just put it, let's say for fun I put it 10, and I click on save. Now close this one. Close. Thank you very much. Now I open this file again. Keyword, and you can see we have material, and this is what we have done right now. Okay, so the material is this one. C is number 10 because I just said it is 10. And then we go to part. Here section is this one is 10, the one we defined just now, and then accept. Done. Okay, click on model, see what do you have. Alright, next we're gonna define the D3 plot, or the database binary D3 plot. Our termination time is 1, so this one gonna be 0.1. Yeah, it's enough. Or I can also make it 0.01. It's a small file anyway, so the output will not be that big. The control termination, and this one gonna be 1. Okay, now if you think about it, you're applying 1 millimeter and the time is 1 millisecond. This is not seconds. The time is in 1 millisecond, which is actually very fast. So what I'm planning to do actually in this simulation, I'm going to use the implicit. The implicit meaning we don't have time step. We don't have time. It's just like a static problem. So here we have implicit auto. This one can put 1 as automatic time step. Then implicit general. This one need to put it as 1 as well, because you want it to be implicit analysis. Okay. 0.001. This is the initial time step. And then implicit solution, just keep it the default, then implicit solver, and accept. So these all the implicit keywords that we need. And I think that's all. Control save. This one is in the desktop. Okay. So open the LS Dyna manager, you browse, you go to desktop, open this one, use all the resources that you have. But actually the problem is big. Okay, actually there is one more thing that I forgot to do, which is actually the main thing about this tutorial. Okay, so what we have done right now, we just covered it in previous tutorials, and in this simulation, what we have done right now so far, we have the ruler, we're gonna apply the load, and that's it. End of story. But we have one important keyword, which is actually the topic of this video, which called where is that fellow? Yes, interface. Here, SPRINGBACK LS DYNA. Okay, this is the main thing that we want to cover in this tutorial, or the most important thing. With this keyword, interface LS DYNA tutorial, first I will define it. So, and then I will explain what it does do. You need a set part, okay? So with a new keyword or new entity, you define this new part set. Click here and then apply, then done, then accept. It's quite very easy to define, right? What does this one? What does this keyword do? What does it do is, stop this. What does it do is, after the termination has finished, it will create a file called dynain file, and in that file, all the parts that you have defined in this part set will be there, deformed, and also with the stresses in them. Okay, so just bear with me. I will close this one. I will save this again, and then I will try to run this. So what do we expect to see in the output file? The dynain file is this ruler and deformed, which is bent in the bent shape, and with the stresses on the elements. Okay, so in this example, I will show you how the spring back will occur. But you can use actually this keyword if you want to do other things, like, let's say, stress analysis, pre-stress analysis. Let's say you have a plate and you want to pre-tension it before applying a dynamic load. So you can use this SPRINGBACK LS DYNA keyword, but you need to use two different simulations. So the first simulation that we have done right now is the implicit one, and from the result of this implicit one, you're gonna do another. You can take the dynain file and do some pre-processing on that file, and then you can carry on your dynamic simulation as usual. So still need to wait. I thought I talked long enough, but it's almost halfway. Okay, so here I can close this one, can open this, and then I can say new folder, and from here I can say explicit. So now we just need to wait for this one. Okay, it's done. It took 2 minutes. So close this one. You can see here is the dynain file that I've been talking about. So you open ls prepost. Okay, this one I just copy it and put it here in different folder. Okay. You need to import. You cannot just drag like that. And now you can see this is our part. Actually is a bit bent. You cannot see the bend so much. Okay, what's more important here, you click on model keyword, you can see this one, initial shell stress. So all the elements of the shall actually have the stresses values on them. And what else? Yeah, so now we can try to do the free vibration simulation. Just run this, apply the thickness, define the thickness again, and define the material properties, and just let it be and see how it's gonna vibrate. So click on the here, let's say define, section, or you can just copy from the original file, open with any text editor here, and this one also, the old one, the original one, open with the text editor. Okay, this is the dynain file. Okay, so what I want is the material mat. These actually all are comments, so you don't actually need them, but if it is there, it's good so that you know what you're doing. The more details that you have, the better. So you can paste it anywhere. I just paste it here, and then I go to section, thing is up, the section is here, just on the top. Okay, so section is ID 1 and material is ID 10. So I go to part, where is it? I can't find it. Okay, it should be somewhere, but it's okay. If I cannot find it here, I just use the preprocessor. Place it, and this one again I need to import. I cannot just drag like that. Import. Line 37. Line 37. I did not modify that. Oh, here. Save this one again. And here, just open new. Okay. Import this one, dynain. Okay, you can see there's a little bit of bend. Maybe I should have increased the displacement, but it's up to you. You can do it after you finish this tutorial, just to test new things. So you have the material here and you have the section here. So you go to part, part, to create it. Okay, extruder, say bent or deformed. Section ID is 1, this one is 10, and accept. You of course can change the thickness and use a different material. It's up to you. And now we go to control and termination, make it, let's say 100, set, and then database D3 plot, make it 0.1, set. Now everything is done. Just name it ruler deformed. Okay. Now you open the manager, explicit, and use all the resources that you have. Oh yeah, one more thing I forgot to mention. When you use the dynain file, when you use the interface SPRINGBACK LS DYNA command, it will automatically generate the boundary condition. So you already have the fixed nodes. So you don't need to define those again. Yeah. It's going so fast. So let's see what's gonna be the result. Okay, termination. Okay, click here, this one. Okay, I can close this one, close this one. Where is it? Is it open yet? No, not yet. Here. So yeah, the vibration, you can see it going up and down. So I can go here, post processing, displacement, and make it 10, and you can see the vibration. Okay, so what we can do, we can go to post processing, history, nodal, and then click on 3 nodes. This is the free end. This is somehow somewhere in the middle, and this is the free end. And then we see the Z coordinate, and this is the vibration. Okay. So red is the fixed end, and green is somewhere in the middle, and the blue one is the free end, and it vibrates from 1 to -1. Of course, if we increase the time step, this gonna stop somewhere. Okay, so let me do this again and increase the displacement, or I just open the file that I did before where the displacement is quite visible. Here, here, I cannot do that. I have I'm opening a file that I did before. Everything exactly the same, except that I have increased the initial deformation. So I want to measure it from here till here. Okay, so it was 10 millimeter. And the one I did just now is this one. The one I'm opening right now is 10 millimeter. And you can see the post-processing, you have the stresses already here. Okay, and you click and see how this fellow will vibrate. And actually somewhere it will slow down and stop. Okay. What is the stress, the value of the stresses? Displacement. Okay. Okay, one last point that I want to mention to you is about the dynain file. I have mentioned about this, but I have not shown you. Okay, I want to open new. Just open the dynain file again. When it is in the dynain format, you cannot drag to the preprocessor. You just need to import. But after you save it and change the name as keyword file, change the format, then you can do it. Okay, here's a file that we did just now. What I've mentioned before, that in the dynain file, when it is created, the initial stresses will be there. Okay, fine, I've mentioned that. But also you can see here, if you go to post processing, so you can see all the stresses are already there. Okay, dynain, which is the name of the file. Okay, so that's all from me today. Thank you very much for watching, and if you like or if you learn something from this video, don't forget to like and subscribe. Thank you very much, and see you next time.